broadcast button on the GoToWebinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. going to start today's session. So, first of all, I'll recap yesterday's session for 5 minutes and then we will start with today's session. So, in yesterday's session, we were looking at from ECC how we can create configuration. So, how an FICO consultant creates an enterprise structure. Based on this enterprise structure, the tables that are generated using data provisioning method, replication to HANA, and we also discuss about two more points. One is about star schema. In star schema, virtual star schema versus native modeling, native HANA modeling using HANA Studio. In the HANA Studio, creating an analytic views based on star joins. First, I'm going to start with how the physical star schemas are created when we import tables from BW. Let us see. And then we will move on to the how to create native HANA data models using analytic views. So log into HANA Studio and log on to HANA Studio. Let us expand content. Right click on the content. I'm just going to create a new package. This is a sample package I'm going to create here. I'm just going to give it as BW import data models. Just going to give this name as BW importing of data models. Just a sample package I'm going to create here just for this exercise. Right click on this package, right click on the package, click new and click on the analytic view. Provide the name an underscore copa underscore actual underscore data. Let us provide the label, which is the description. View type is an analytic view. package pw import data model and click finish. So once we click finish, minimize this job log. I just want to minimize the job log. And in the scenario pane, I'm just trying to expand the scenario pane. Now once we click on data foundation, you see the same options: details, output pane, properties pane. At the data foundation, I'm going to click on this plus icon, add objects, and add required tables. So I'm adding the following tables: KNA1. I'm using the schema called best KNA1 from. So instead of HANA user, I'm taking from best schema. KNA1 T005T T005U Mara material master table this MAKT T001 TVKO. So I want both these tables, TVKO and TVKOT, TCURT, and the last table CE1 IDEA. Now that we added all the tables that we require at the data foundation, so the added tables of the data foundation we can see in details pane. So I'll just try to only work on this area. This is the details pane, so I'll try to minimize everything. I'll minimize where used, I'll minimize system, I'll close this scenario pane and close this output pane. Everything close. And we'll try to organize these tables first. We'll organize these tables. So KNA1, T005T, 5U. We know the relationships between all these tables. So I'm just trying to organize these tables so that it is easier for us to make joins. So here you have Maram, MAKT, and here we'll keep another central table as the last table that we have here is CE1. I'll select this table and just bring to the middle of all these tables to the center. I'm just dragging and dropping this table to the center. And then the other tables that we have here, I'll bring T001 to the center here between these tables. We don't have to organize, but just to make these joins easier, just I'm trying to organize them. Okay, so let us start from the left side. Now we know all these tables are column tables. All these tables are from best schema. So same relationships I'm going to define here. Land 1 to land 1, land 1 of KNA1 to land 1 of T005U, regio of KNA1 to BLAND of T005U, and then each of these joins, join type is a text join, language column, SPRES. Now we know why we're doing this, because we discussed in the past. So we again take this as a text join and SPRES. So this is the customer tables. So all these are customer tables. So first I'll complete the joins part, and then we will move on to the selecting of these columns. So MATNR to MATNR, and then the join type is a text join, because we're joining text tables. Again, I'll come to the right hand side and I'll join T001 BUCARES to BUCARES, VKORG to VKORG, and then I'll join WAERS to WAERS. The same type of joins, and this is an inner join, and this is a text join, and this is a text join. So this is a text join, and then now this is the center table. So yesterday we discussed about the relation between the master tables and the transaction table. So this is the transaction table. So we need to join the key attributes, the key of the table from customer to the fact table. So this is a fact table, and these are master tables. These are master tables. I need to join with the fact table. So yesterday we discussed we need to join KUNNR with KNDNR. So I'll link KUNNR from KNA1 to excuse me, KUNNR to KNDNR. I'll link MATNR from MARA to ARTNR. And I link BUKRS of T001. Excuse me. So let's scroll down and search for BUKRS and link to BUKRS. So each one of them is a subject area. So here you have customer subject area, you have material subject area, we have company code subject area, and these different subject areas I'm linking with the foreign keys of the transaction table. Now we know these are the foreign keys: KNDNR, customer, material, and then here you have BUKRS, which is the company code ID. Now let us do field selection for output. Now we know the joins between each of these tables. So let us start doing selection for output. So output, I'm just expanding this window that is hidden inside. I'll expand. Now we don't have any output column, so slowly I'll start selecting these columns: customer, number, name 1, region text, and then land 1, country ID, then land text, country text, and then I go to material, MATNR, MAKTX, material text, and material group, MATKL, MATKL, material group. So I'm selecting all these columns to the output here, and then first I'm completing the master data. So then I go to BUKRS, and BU text, company code text, land one. So no, we don't require land one. So when you don't require, yes, we can select this, right click and remove, click OK. So WAERS, L text, currency text, and then sales organization and sales organization text. So these are all, I selected the master data, customer materials and company codes. We selected all these master data attributes and texts. Next, I'm going to go to the fact table, which is the center table. Now in here, this center table, I'm going to click on find column, and I'm going to enter VV010. Now this is gross revenue. This is the revenue which is gross. So I'll highlight this column. Now this is a measure which is amount related data. And the other measure is VV070. This is deductions. What are my sales deductions? VV070. So both of them I have again in the columns. So I'll close this find. I'll scroll to the top. So if you want, we can just zoom in or zoom out. So this is the view that we just created. Now I'll open this scenario pane. I'll open this scenario pane. I'll click on star join data foundation. So in the star join data foundation, at the data foundation, here we see all the selected columns of the data foundation. So here in this data foundation, I've defined a relationship between multiple tables, master data, the center table is the transaction data, a linked primary key with the foreign key, and selected the required measures. The output of the data foundation is available at the star join data foundation. Now this output is finally in the semantics. In the semantics, if you see, all these columns are available in output. All I have to do over here is just click validate. Once you click validate, system automatically will identify whether this is an attribute or a measure. Now if you want to manually do it, we can do it. So type, it's an attribute or a measure. KUNNR is an attribute, double click. VV0 is an attribute or a measure, it's a measure. So if you have the other columns, when you click validate, automatically system will identify whether these are attributes or measures. So this is a measure, aggregation type is sum, this is the default aggregation type, and I'll finally click save and activate. So I'm assigning the object to change. So whatever the change, I can click new. I can give the name. assigning this to a change and click finish. So we will discuss more about this in the lifecycle management. So I'll just click finish for now. So once we activate this, click on this show log, completed successfully. Now once this data model is completed successfully, I'll click on restore. I'll restore this, restore. We'll go back to this package, BW import data model. Now this is the analytic view. Now I'll right click on this analytic view. I'll right click on the analytic view, click data preview, click data preview. Let us select BUKRS, drag and drop into the labels axis, select measure VV010, drag and drop to values axis. So now I'm trying to basically BUKRS is an ID, and here you have BU text, which is the company code text. So here it's displaying the company code and the gross revenue based on company code. So I'll click on the table view. So here you have different views like chart, table, grid, HTML. I'll click on table. So this based on gross revenues based on different countries is actually displaying a gross revenue. And still we can, I'll just try to filter over here. You see it has taken 31 milliseconds to produce company code and their gross revenues. So I'll go to filter now. I'll try to filter. So I'll select company code. So is there any disturbance coming in? Hello? I see some participant message, the disturbance is coming in. Okay, thank you. So here we have a company code. I'll select this company code, drag and drop to filters. So when I drag and drop company code to filter, these are simple filters. Simple filters in the sense I can select only 1000. You cannot have multiple selections. Just for 1000 company code, this is my gross revenue. And further what I want to do here is, I still want to go in detail. For this company code, customers, I'll drag and drop name one. Now it's actually displaying me based on customers, gross revenue. For Germany company code, these are different customers. And based on these different customers, we are seeing the gross revenue. Now again, company code, customer, each customer is purchasing what materials. Again, it taken 51 milliseconds. I'll select MAKTX, which is the material text, and drag and drop to labels axis. Now again, we are displaying based on different materials. So these are different materials. So these are different customers. So each customer is purchasing a different material. Customer is purchasing a different material, 104. This is a gross revenue. Same customer purchasing a different material. This is a gross revenue. Same customer purchasing a different material. This is a gross revenue. So all these are customers and materials and their gross revenues. Please see, again the time taken is 76 milliseconds. Now for the same report, now I don't want to see now again. I'm basically seeing in a company code, customers, in a customer, what materials has been purchased, each material, what is the gross revenue. Suddenly, I want to remove everything. and only see by company code. Again it has taken only 24 milliseconds. So the time that you see is taking approximately from 20 to 70 milliseconds, means less than a second. The same report you want to generate, the same kind of reporting you want to generate in the ECC. You can display different kinds of graph, horizontal bar. This is only for developer preview. So usually this is not for the end user, where this is only for testing purpose for a developer. But only for test purpose for a developer, he can just view in different charts, tuck clouds, pie charts, waterfall charts. So in the analysis, all the available objects, filters, labels access, we can drag and drop the attributes, we can drag and drop the measures, and here we can do the analysis. So what a point I'm trying to highlight over here is, the first point I would like to highlight here is, let's go to the data model. Let's go to the data model. Let us click on the data foundation. Let us understand from the development point of view. Now we know for these set of tables, we already created an attribute view called customer. For these set of tables, I already created an attribute view called material. And for these set of tables, we already created another attribute view called company code. Now, so what I'm trying to highlight over here is, now there are two ways that we discuss. One is native HANA modeling. Data modeling inside HANA, reusing the attribute views. We reuse the attribute views, means in the data foundation of an analytic view, what I'm doing here is, I'm just taking these tables again. All these tables I'm taking again. KNA1 table, T005T table, T005U table. I'm creating an analytic view, I'm taking in the data foundation. But we also know for the same set of tables, when we create the attribute view with the same join conditions, we also created an attribute view called AT customer, AT underscore customer. So attribute views are used to join master data tables. They execute on join engine. Join engine is optimized for processing complex joins. So this is what we have seen in the last week session. Now this week, what I can do is I can actually reuse the same attribute view inside an analytic view. But I'm not doing that. But simply I'm taking these tables again for the ones that I've done in the last week, creating material, creating company code attribute view. I created all this in the last week. I'm not using them again. I'm actually joining these tables again in an analytic view. So what I'm doing here, I'm taking these tables, joining these tables together again in an analytic view. So this is known as physical data modeling. Now why this is known as physical data modeling? I'll give an example. Now we know tables are always in the database layer. So tables at the database layer. The tables are spread across at the database layer. Now these tables we access in the ABAP application layer. So usually what we do is, we don't touch the database at all. Now, when you're working on the ABAP application layer, and this is the database layer. So always what we try to do is, we actually don't touch these tables in the database layer. We even don't have access to them. Now what we try to do is, we actually call all these tables to ABAP layer. Let's say these 3 tables I called here. And I'm creating a relationship in the ABAP layer. So usually all these relationships we are doing in the ABAP application layer. Now what I'm trying to do, the same relationship I'm creating at the database layer. So this is what a BW is doing here. This is what a BW. So BW is nothing but business warehouse. BW executes on an OLAP engine. So whenever we execute cubes, I'm just trying to introduce a new terminology, which is a cube. Cube is nothing but a multi-dimensional object which is based on a star schema. Cubes are available on the BW. Even the cube is also available in HANA. The cube in HANA is known as analytic view. The cube in a BW is known as info cube. Fundamentally both are same. Fundamentally both are same. An ABAP application layer access the table from database, and we create relationship between these tables in the application layer. So this is what a BW is doing. So now we are defining the relationships in the ABAP application layer. We can import these relationships from ABAP to HANA. So why are we actually importing these models that we created on the BW? So yesterday we have seen one option in the HANA Studio. If you go to the HANA Studio, I'll click on File, click Import. When I click Import, expand SAP HANA Content. Once you expand SAP HANA Content, here we see SAP NetWeaver BW models. Select this mode to import objects available in an SAP NetWeaver BW system that you want to transform into SAP HANA information models. So there are also a scenario where you don't have the BW application layer at all. Now, for example, in SAP there are more than 2,25,000 customers. In 2,25,000 customers, only 14,000 customers use BW. In 2,25,000 customers, only 14,000 actually use BW. But HANA is relevant for all the 2,25,000 customers. Now, most of the applications in SAP can be powered by HANA. For example, here you have BW. I can have another SAP system called ECC. ECC system is powered by HANA. CRM is powered by HANA. BW is powered by HANA. Oracle apps, Oracle apps, non-SAP, is powered by HANA. E-commerce, you can create your own e-commerce website powered by HANA. So similarly, BW is also powered by HANA. So whatever the investment we already made on the BW, customers are using BW from long time. So whatever the investment we made it here, still we can import that investment into HANA. When we import these cubes, which are already created When we import this, these create analytic views. So when we import these cubes, they create analytic view. So this is how they get created. This is how they get created. Means we are not creating attribute views. They don't create attribute views. Just this is also a star schema. So this is one dimension, this is another dimension, and this is the center table. But what are we not doing here? We are not having attribute views. So whenever we do data modeling in HANA, instead of doing this way, getting all the tables to the data foundation, we use attribute views. We use these attribute views in the star join data foundation. So in the star join data foundation, what we can do is output is same, but how we model is different. The same attribute view, I can drag and drop. TC. So this is customer here, KNA1, T005, T5U. These three tables I'm actually using in the data foundation. But let's say I can, in the star join data foundation, I can click on this plus icon, add objects, and I can give an AT underscore customer. I select AT under customer and I can select, click OK. So I can have this AT customer like this in this task. So when I open this, when I click, right click and open. So here is the attribute view called AT customer. But here we have only two tables. The other table is deleted. So when we're actually doing the same thing at the data foundation, so whatever we do here, this is imported from BW. So when you create a star schema at the data foundation, or we can create at the star join data foundation, both of these data models still execute on OLAP engine. Again, I want to clarify one more thing here. So when we're working on the ABAP application layer, the engine that process this data model. So we say BW is an OLAP system. BW is a OLAP system. So when we say BW is an OLAP system, optimized for reading of data, it's optimized for reads. ECC is an OLTP system, transaction processing system. So when we are not importing these models that are created in BW, when we're not importing these models, means we're not doing this actually. Still the models are in the BW. When we execute this data model, means user is reading the data. User is reading data from these data models. It executes on the OLAP system, OLAP engine that is inside the BW system. When the BW is on HANA, there are two OLAP engines. One OLAP engine is on the BW and the other OLAP engine is on the HANA system. HANA is a combination of OLAP plus OLTP. So traditionally, if you see in SAP, some systems have OLTP system like ECC. Some systems have OLAP systems like BW. So engines are basically divided based on systems. ECC is an OLTP system, BW is an OLAP system. But SAP don't want to divide this. Like some system does OLAP, some system does OLTP. So instead of that, what SAP has done is, Inside HANA, they have both these engines, OLAP system and OLTP system. So now the next question is, when we're importing this, when we don't import, when we execute this data model, it exploits the engine on the BW. But we have the same kind of engine that process this data model. We have the same kind of engine in HANA. So when we're importing this data model to HANA, the data model is an analytic view now. So InfoCube technically is an analytic view. So which OLAP engine does it use? Does it use the engine that is in HANA, or does it use the engine on the BW system? So when you execute the data model on the BW system, it exploits this engine. When we import this data model into HANA, it exploits the engine inside the database. Okay. Now what is the advantage of importing these data models to HANA? What is the advantage? The advantage is, now you see, this is a different layer and this is a different layer. So two layers have to communicate to each other. The logic is here. How to process the data means the business logic, how to process this data is here, but data is here. So whenever we execute, whenever we try to read data, we're trying to read data. Whenever we read data, it picks the logic. So based on this logic, it goes to the database, gets the data from database, again back to the application layer and to the front end. So instead of that, what we are doing now when we import, we're also having the logic and data close together. So logic is down, data is down, data plus logic. Data is nothing but the data inside the tables. Logic is nothing but the relationship between these tables. Both are at the HANA, and even to process logic and data, the engine is also at HANA. Nothing but performance. Leads to good performance. So whenever we keep data and logic together and the engines to process this data together, we actually keep all together in the database. It is faster and efficient. Instead of keeping data over here and logic here and the client is here, client is doing a read, go logic and go database. So instead of having multiple layers, so whenever we increase the layers, obviously it degrades the performance. We decrease the layers by keeping the logic and data together inside the database. So the read is actually happening on the here. Now something like this. Now I did not import actually the similar kind of data model. I'm actually creating it native HANA. How we can import, I can show you a later point when we discuss about BW powered by HANA. But because we have the analytic view topic over here, I just want to highlight a data foundation is a place. A data foundation is a place to define a relationship between tables. When creating data models for native HANA, we use this data foundation for transaction tables. The output of the transaction tables. Now, what is a transaction table? A table contains measures. So I'll copy this data model. I'll copy and paste. Right click on the folder, click paste. And just try to copy this quickly. And click OK. Object is copied. Object copied. Click OK. Double click on this data model. Double click. Just remove all these tables. Just I'm going to modify this view. I'll select all these tables. I'll select all these tables. You see orange color highlighting. Right click and remove. And click yes. And click OK. And click OK again. So it's basically removing all these tables. Few more tables are there. I'll just remove all the rest of them as well. So here we have C1 IDA table. I'll insert two more tables. VBAK, VBAK. So this is the sales table. VBAK is the sales table. Now, what I'm going to show you now, what am I trying to show you here is we discussed one point in yesterday's session. So yesterday's session we discussed one point. So a data foundation, I'm still focusing only on the data foundation. So I'm just trying to focus on the data foundation. The things that you can do in the data foundation of an analytic view. So that's what I'm trying to focus here. So first is a data foundation can be used to import data models from BW, and when you import these data models, they create star schema. And this star schema executes OLAP engine at the native HANA. So whether you create a star schema as a data foundation, but what are we not doing here is we are directly joining tables together. We are directly joining all the tables, master data, transaction data, all these tables I'm joining together. And the output of this is actually executing on the OLAP engine. So this we see just now. The second thing here, transaction tables. The first one, master data and transaction tables we are using when we use BW import as a star schema. Now, we have two tables here. One is VBAK. Excuse me. We have VBAK and VBAP. These are sales tables. Now, if you see, both these tables are transaction tables. Both VBAK, because both contain measures. VBAK is a sales header table and VBAP is a sales item table. So if you see, there's a column. If you click find, NETWR. So NETWR here is net value of the sales document. This is the net value of the sales document. And here also NETWR is the net value of the sales document. So in both these tables, if I click on this, if I click on the NETWR, so this NETWR is from VBAK and VBAP NETWR. Okay. So we have NETWR from both these places. Okay. Now, yesterday we discussed we cannot request measures from more than one table at the data foundation. So there are two tables over here. Table 1 is VBAK and table 2 is VBAP. Now, for example, there's another table like VBAP is there. You can take VBRK, VBRP, any of these tables. VBAK gives order related data, whereas VBRP gives about billing related data. This is order related information and billing related information. Now, for what orders, what bill is generated, ordered quantity and billed quantity, or any table you can take. But the point here I'm trying to highlight here, we cannot request measures from more than, either you can select measure from here, either we can select measure from here, either you can select measures from here, but any measure should be from a single table. Now, can I request attributes? Attributes are nothing but I join these tables together. But my requirement here is I want the order ID. For this order ID, what is my bill ID? Nothing but the invoice number. So what I can do here, I can join order ID of VBAK with the nothing but order ID of VBAK sales order. This is the sales order. And sales order in VBRP, nothing but billing table. So only when I join order 001 is an order ID. 001 is an order ID. Only when I join order ID to the order ID of VBAP, I can get this bill ID. Because I need to join order ID of order table and order ID of billing table. Then I can get the bill ID. So 001, let's say the bill ID is 005. Okay. We can request attributes from two different tables in the data foundation, but not the measures. The point I'm trying to make over here is we can request measures, we can request attributes from two different transaction tables, but we cannot request measures. So we can join VBAK and VBRP. VBRP. I'm just trying to explain the scenario here. So here you can see this is a VBRP table. The VBRP table, here you have billing document. Let me get this description, tables which have descriptions so that it is easier for us to understand. So here in this scenario, we have VBRP and here we have VBAK. So this is bill document. VBLN is a bill document and VBLN is a sales document over here. So what is my order ID? For this order ID, what is my billing document? I need to get both these documents to the output. So what I can do here, so can we see sales document? Can we see another sales document here? So here you see another sales document. AUBL is a sales document. And here also you have sales document. So can I join VBLN of VBAK with that of AUBL? AUBL is also a sales document. So I'm joining two tables together. I'm getting the sales document. So based on the sales document, which is the sales document from VBAK, I can get this billing document. I can request attributes from two tables. But if I request a measure, for example, here I have in this, I have a measure called NETWR. This is the net, okay, this here, this is the net value of the sales document. This is the net value of the sales document, and this is the net value of the billing document. So can I request two measures from two different tables? Cannot. So now we know what we can do in the data foundation and what we cannot do. First of all, we can create a star schema. We can create a star schema. When you import data model from BW application layer, you can join master data tables to transaction data tables and create a star schema. The second point here is when we are creating native HANA data models, when we are creating native HANA data models, this space is mainly used for transaction data, not for master data. Because master data is already created in attribute views. And these attribute views, I can drag and drop into the star join data foundation. I can drag and drop into the star join data foundation. I don't have to take tables again in the data foundation. So when you're using the transaction tables, so what is the limitation? You can request measures from a single transaction table, but we can request attributes from multiple transaction tables. Like for example, now we have seen one example, like what is the sales document ID? For that sales document ID, give me the bill ID. Either you can see for this bill ID, what is my net value of the sales document, or for this order ID, what is the net value of the sales document? Order quantity, ordered net value, or billed net value, but not both of them together. If you want to see both of them together, then we have to create two analytic views. With a similar data model, we have to create two analytic views, and both of them we have to use in a calculation view. This is one scenario. But we cannot get measures from both, but we can still get an attribute. Now, if your requirement is something like this, get order ID, get bill ID, get net value for any of them, but not for both of them, then one analytic view would be sufficient. But if you want to get both the measures, it's a limitation. Can we see this? I'll show you the limitation, what error message it throws. I just want to delete tables that I'm not using here. All this is just to show the limitation of an analytic view. And also at the same time, I'm trying to utilize this time to show you the star schema and the data foundation. So to sales document, to the okay, sales document to sales document, and then So this is net value of the billing document, and the other one is net value of the ordered quantity, net value of the ordered amount. So we have VBLN and also VBLN. Sales document, billing document, net value, net value. So now I'll click on the star join. So in the star join, we have sales document. This is billing document, net value of the billing, net value of the sales. Now, let's go to the semantics. So billing item, billing ordered. So here, I'll validate, click on save and activate. Now please see what system is doing here. So previously, when I validate and activate, it appropriately selected what are measures and what are attributes. But this time, system is not able to understand what are attributes and what are measures. The reason is we are requesting measures from two different tables. You see, we are requesting these measures VBAK NETWR and VBAP NETWR. So both, NETWR VBAK and NETWR VBRP. The system is unable to understand why we are requesting measures from two different tables. By right, you should be doing from one table. So that's why system confused, and it is actually showing everything as an attribute. So when I validate and if I click on activate, if I see show log, now there is an error over here. What is this error? Double click on the error, and click on this error message. So what does it say here? Encountered an error in the repository runtime extension. Central table not unique. Attributes defined for different tables. Now it's actually telling an attributes because system understands them as an attribute because it's taken as an attribute. Because I did not do anything, system automatically takes this one. But suppose say I forcefully change to a measure. I forcefully change them to a measure. Now this time let me validate and activate again. And again it throws an error. Let us see this time what error. Double click on this error message again. Again it says encountered an error in the repository runtime extension. Central table not unique. Base measures defined for different tables. So it's actually the error is because the measures, not the attributes. So what system is saying, why we did take measures from two different tables, which is a limitation of an analytic view. So I click OK. I click OK, and also you can see one more message over here called central table not unique. It means that we need to have only one central table. That central table name is the fact table. The center of the star schema is the fact table. Now why there are two tables? Why there are two fact tables? Why you are requesting measures from two different fact tables? So click on the data foundation again. Now when you click on the data foundation, here you see one property. When you click on the data foundation, here we see one property called central entity. Now what is the central entity? Central entity is nothing but the table from which you want to request the measures. So what is the central entity you want to select? I want to select what table? Either you can select VBRP or VBAK. You see, you have only one option to choose. If I choose to go for VBAK, means the central table is VBAK. So VBAK is a fact table, means I can request measures from only VBAK. So I'll go back to VBAK now. I'll go back to the data foundation. I'll go back to the data foundation, and then I'll go back to the data foundation. Where are these tables? Okay. And I'll remove this measure now. I'll remove this measure. I'll remove the measure from VBRP. So VBRP and ETWR, just select, right click and remove, and click yes, and click OK. Now let us go to semantics again. Now you have sales document, you have billing document, you have NET sales value, net value of the sales order in document currency. So I'll validate again, save and validate, and save and activate, and click finish. Now let us see show log. Successfully completed. Completed successfully. So now can I right click on this and right click on this data preview? Now here you have VBLN. I think we don't have data in these tables. So I think data is not there. Okay, let's select VBLN and NAWR. So you can check quickly whether you have data or not. You can go to the data foundation and you can do a quick check. Right click on this table, VBAK, and data preview. Click data preview and just click raw data. Click on raw data. So the table is empty. The base table is empty. That is why I'm not able to see any data in the output. If you have data, we can see this because someone else created these tables. I'm just reusing them. So the point here is when you have this VBLN sales order billing. So now please see, did I request attributes from two different tables? Yes. So this scenario is possible. So you can request attributes from two different tables, but not measures. Measures only from a single fact table. And we can create a star schema. And the star schema that is, we can import the star schema from BW. The star schema that we import in the data foundation executes on OLAP engine. So these are the 2 points I would like to highlight for the data foundation. Now we know what we can do in the data foundation. One is importing the data model from BW to the data foundation creates a physical star schema. The star schema execute on the OLAP engine in the native HANA. It increases the performance when you have logic and data close together. It's faster. But the disadvantage of going to this, there is also a disadvantage of going to this kind of modeling. So when you import these data models, there is an advantage when you compare with BW. When you compare with BW, there is an advantage, but the disadvantage when you compare with native HANA is the reusability. We lose the reusability concept of attribute views. So why we lose reusability? Please see, every time when I create a data model, I need to select these tables. Now these tables are specific to this data model. I cannot reuse. If I want to reuse, what I can do? KNA1, 5T, 5U, keep it in an attribute view. You can keep this in an attribute view. Whenever you want, you can just drag and drop the attribute view. Because the attribute view will contain all these tables again. So The disadvantage of importing BW data models, or we create data foundation, we create the star schema as the data foundation. Disadvantage is we lose the reusability. So instead of that, we create an attribute view, a reuse. That's why when in the definition of an attribute view, we say it as a reusable dimension. It's a reusable dimension, means we can reuse in n number of analytic views. We create only once, but we reuse. But here we're actually doing an extra effort again to join these tables in every data foundation. Okay, let me summarize these 3 points again. Point number 1. When we import BW data models, it creates when we import BW data models, it creates a star schema in the data foundation. This star schema is known as physical data model. The disadvantage of this model is we lose the reusability because we're not using attribute views. It's creating a star schema as the data foundation. But the advantage is the performance, the OLAP engine, data, and the logic is close together. Point number 2, we cannot request measures from two different tables in an analytic view. We can request attributes, but not the measures. Third point, in the star join data foundation, when you're creating a star join data foundation, the star schemas can also be created over here. A star schema when created here, both of these, either it is from BW, either it is from HANA, both of them execute on the OLAP engine. So today we only see the data foundation, how it creates when we import data models from BW powered by HANA. And tomorrow we'll see the star join data foundation. Thank you. So let us see the questions now. Let me see the questions that we have. So why this is for end user? Why not this is for end user? Okay, I think the data preview. The data preview is also for end user, but they will use Bibo BI reporting tools. The data an end user will visualize in different reporting tools like Lumira, Crystal Reports, Design Studio, Web Intelligence. So there are another set of tools where end users can actually visualize data. But for a developer, for quickly preview data, he does it in the HANA Studio. What is the join type we are maintained for central table? Please show me again. The join type automatically system takes the join. So by default, it takes as a, when you actually double click on 2, by default system takes as a referential join. But still you can change these joins. It takes as a referential join by default. The referential joins are similar to inner joins. They're similar to inner joins, but just that referential integrity is maintained between two tables. So the default join is a referential join when you join two transaction tables at the data foundation of an analytic view. So next question. What is the schema which we have to create now? Is it imported from BW? what is the schema in which we have to create now? Which is created now. Is it imported from BW? Okay. Okay. So BW is an ABAP application layer. BW is based on ABAP. It's basically an application layer outside the database. HANA is a database and also an application platform. HANA is a database. Also, it is a application platform. BW is an application layer but not a database. So BW powered by HANA means BW is on HANA. It exploits the capabilities of HANA. It exploits the capabilities of HANA to take advantage on the application layer. So basically, HANA complements BW to have more advantage to business. So whatever the ABAP application layer, whatever the things that we do in the ABAP, in the BW, participants who are new to this SAP concept, so most of the things that we do in ABAP, we only have the logic over here, not the data. Data and the container or the content is always in the database. But how these tables are or the logic, how the data is processed, we have in the ABAP layer. So what I'm trying to say is, when the BW is on HANA, whatever the tables that we create on the ABAP application layer, it is not only for BW, it is for any SAP application. It's actually, there's a default schema. For example, please see, I'll just try to show you. If we go to SAP logon, I'll go to SAP logon. I'll go to BW here. We have BW on HANA. We have BW on HANA. I'll give the username and password. I'll provide the username and password. Here I click on systems, click on systems, click status. And here you see, okay, this is on MS SQL. This is not on HANA. Please see, the BW system that we see is on the MS SQL. But this is not the solution I'm looking at. I have to log into a different system. I will have to log into HANA. This is BW74 on MS SQL. I have to log into HANA. So click on systems, click on status, click on systems and status. Here we see database HDB. HDB database means HANA database. So owner, SAP ABAP 1. SAP ABAP 1 is the owner. So if you go to HANA Studio, can we see this owner? If I expand catalog, SAP ABAP 1 is a schema. So in the application layer, we see the HDB is nothing but the database. Inside this database, BW is actually storing all its tables in this schema called SAP ABAP 1. So when you expand this, even it is same for ECC. If you expand ABAP, if you expand tables, here we see the tables. All these are standard tables. So to the question was, what is the schema which we have created now? Is it imported from BW? So all the tables of BW, all the tables BW creates is in the default schema, that is SAP ABAP 1. All the tables that we create on the ABAP is inside the HANA database in one schema. It's all grouped, all BW tables are grouped in one schema called SAP ABAP 1. Even when you have ECC powered by HANA, all the tables of ECC are grouped under one schema called ECC schema. like all the tables of SLT into one schema, all the tables of BODS to one schema. So we're basically grouping these schemas based on the application usage. And we select these tables to create data models in the content area. Next question. See, is the upgrade still happening? I'm not able to connect to the remote desktop. Yes, just testing is going on. I'm going to test and release to all of you. Just give me another today and tomorrow. Once the testing is complete, we'll take complete backup so that you don't have any issue. We are upgrading to the new version to see new features. By tomorrow, everything will be finished. There are two versions. One is 9 and 10. You're giving HA 100. Which version I can study? Benefit for certification. In certification, you can have two certifications. One is SP9 and SP10. If you're going for SP9 certification, then please read SP9 materials. If you go for SP10, then go for and read SP10 materials. So how will you know what certification you are going for? Whether it is 9 or 10. So you can see the code from SAP. If you have 14, 2014, then SP9. 2015, SP10. The code 2014 for SP9, then you have to read SP9 materials. If you're going for certification on SP10, then you have to read its SP10 materials. So I suggest go for always latest one because it benefit for you if you're in the latest in the software. Tables are available in the HANA also. Why we are using in BW? So BW doesn't contain tables. BW doesn't contain any tables. BW is only an application layer. It seems like tables are in BW, but these tables are inside the database. You see, just now I show BW system is actually using SAP ABAP 1 schema to store all its tables. That is known as BW schema, to store all its tables. So how to process these tables are inside the, how to process these tables is in the BW application layer. But still you can import that. So is there any reason we cannot use facts from two different, is there any reason that we can't use facts from different tables in an analytic view? Because that is the limitation from SAP. I will tell you a different approach. If you still want to use facts from two different tables, you can denormalize data models. Now we are seeing normalized data models. Normalized data models in the sense all these tables are on the OLTP systems. What we can do is, in the process of moving these tables from one system to a different system, we use data provisioning methods like BODS. So instead of getting data from two different tables, if you still require, there is a workaround. You can use a workaround to get these two tables data into a single table. We can do this in the ETL. We can do this in the ETL based on different join conditions or based on you want to combine data. We can still denormalize tables in the ETL process. In that scenario, you'll have, like say, 4 tables. Each of these tables have one measure. Four tables become one table. All the four measures are available in single table. So when you have four measures in a single table, you can create an analytic view on top of it, rather than creating a calculation view. We'll discuss that scenario also in future session. So if a scenario of a single column, Landex has to be displayed in two languages. Yes, you can still display, but never, you can still display technically, you can create a filter. But never in SAP we do, it is not a best practice to do that, because never a user want to see one description in multiple languages. All that he want to see descriptions in a single language, because to understand in his own language. So why do we have to see in Chinese or English at the same time? So that's why in SAP, whenever we log on, but still you can achieve technically, but not a best practice, but things sometimes we can achieve which are not best practice, but still we can achieve technically. In SAP, whenever you log on, you see there is something called language key in SAP. So in SAP, whenever you log on, you see there is something called a language key, log on language. You can choose only one language. We do not have selections for multiple language here. Even when the user is actually seeing data, he has only one language to see at any point of time. For example, if I give now this is shown in English. Now if I log off and log on again, instead of English I choose D. This time it is showing in German. SAP name something in German it's showing. So all this menu has changed now. It's in German. So so even in reporting, you also have a single language, but you can create. If you still insist to see, then you have to customize, or you have to basically create design time filters. Even when you log on to HANA, not only to HANA, even when you log on to HANA, properties, additional properties, there's only one language we can select. Even in the reporting, when you log on to any reporting tool, you can select only a single language. So let us see the next question. So if a scenario has to be output for the same column Landex, two different languages. So okay, you can go to the. I already shown in the first session. You can refer back to that session, or I can show it again for you. We already discussed in the first session. It's already there in my video, but again I'll show you. For example, let us take any of the view. For example, here you have SPRAS. Right click on this, apply filter. We don't have sufficient privileges. Okay, let me check any other package. So here you're taking this as a text join. You're taking this text join means you're actually getting the language based on user session. So same thing, what we can do here is just remove this, take the table again from add table, and here you can add T005T from the schema, which is SLT underscore ECC67. So it creates an alias table, and then here you can join these tables, land1, again landx. So this join you're taking as a text join, and here you can create a design time filter. For example, you can right click on SPRAS, apply filter, and you can choose the language you want. So you're applying a filter on this. So one is a text join based on the user session, but here you have landx from both of them. This is from alias table T005T, and this is from the main table. So validate the tables. So I'm not sure what is one, but I'm not sure whether we have data for one or not, but let us check. I click on attribute view, click data preview. So here landx, sorry, you have to drag and drop here, attributes in Chinese, here in English. And then here you have customer. So now you have in both these languages, landx in Chinese. So like this you can achieve, but this is not a good practice. But still you can achieve this technically, it is possible. So let us go to the next question. So is it not necessary to give a key field in the semantics of an analytic view? No. It's not mandatory for the analytic view. It's only for attribute views when you want to join key attributes with the foreign keys. So please send me the assignments that you have done. So usually the assignments, you can send me an email, the output of each of the assignment that you have done. So I will look at it. So all the assignments that you have done, please send me an email. I'll look. If you're interested for me to look, please send me. I'll just look at it. But the systems are not available now. So I think by tomorrow we will revisit the system again and we will look at it. If you've already done some assignments, please do send. Taking a screenshots, just you can send an output for each assignment. Thank you everyone to attend today's session. I'll see you tomorrow, same time. Thank you and have a good day. Good morning, good evening, and good night to everyone. Thank you.